Hi, Miss Stewart. How you doing?
I'm great,
All right,
Mr.
good.
Haas. How are you?
We're going to graph some linear functions today, and I'm going to start with a real easy one.
That sounds good.
How about the function y equals x?
A classic.
Yeah, that's a classic, and I'm going to do this old school. I'm just going to plot a few points, a few xy points.
I love that.
Right? If x is 1, hey, y is 1, right? They're equal. If I plug in 1 for x, y is got. I think you see what's going on
Can I
here.
use a calculator for this?
2, no, I don't think you need a calculator. 2, 2, 3, 3, x and y are the same. So of course, 1, 1, 2, 2, 3, 3. This is my line right here. Oh, I missed a point. That's my line, y equals x.
Beautiful.
Yeah. Now I'm going to change this just slightly. Now I'm going to graph the function y equals 2x.
Ah.
Again, yeah, I know, getting tricky. Again, I'm going to draw a little table here. And I'll plot the same points. I'll put in a 1 for x. 1 times 2 is 2. I should say I plot the same x values, right?
Yeah.
If I pick a 2 for x, 2 times 2 is 4, y is 4. I'm not going too fast, am I?
No, this
2
is
times
great.
3 is 6.
Plugging in
I'm
an x,
gonna-
getting an
yeah.
y.
Right, you can always do that with any function.
Any
Plug in
function.
an x, get a y. So I'll plot these points. I have the point 1, 2. I have the point 2, 4, and 3, 6. That's
Somewhere off there.
up there like that. And
So it goes through the origin there.
hopefully I'm not too
Ooh,
off. Yeah, so
That's
this is
steeper.
my function y equals 2x. Yes, and of course it's steeper. As a matter of fact, the slope of this function, I think you can pretty easily see, that it is 2.
2.
Right? If I go up 2 in the y direction and over 1, I'm back on my function. Up 2 again, over 1, up 2 again. Yes, the slope is 2, and perhaps you remember the number in front of the x is in fact the slope. So the slope is 2. If I wrote something like y equals 1/4 x, the slope would be
1/4.
1/4. Up 1, over 4. You know how that works.
Yeah,
I'm
fantastic.
gonna graph one more real quick.
This is looking good, Mr. Haas.
I'm going to graph, well, maybe I'll erase this one. I'm going to graph the function y equals 2x minus 3. How about that? Get a little bit tricky.
I'm liking this.
So again, I'll pick some x, y values. I'll put in a 1 for x. 1 times 2 is 2. Minus 3 is negative 1. I hope you'll let me know if I mess this up.
I will.
I'll put in a 2 for x. 2 times 2 is 4. Minus 3 is 1. And I'll put in a 3. 6 minus 3 is 3.
3.
Did I do that right?
Yeah, well, let's check. Let's look at the change of y over the change of
Yes.
x. So
Now-
the change of y went up by 2, and my x went up by 1. Then from 1 to 3, I went up by 2, and my x's went up by 1. Yeah, we
Brilliant,
have
Ms.
a slope of
Stewart.
2.
Right. This is a linear function, meaning that the y's have to go up by a constant amount, and assuming the x's go up by a constant amount as well.
Love
Right?
it.
It's a constant change there. So if I graph this one, no big surprise. I'll put in a 1 for x, and I get a negative 1 down here.
Ooh.
And I'll put in a 2 for x, and that's 1. And then I'll put in a 3. 3 is right about there. Why does this look a little messy? I hope I'm doing this right. Well, it looks a little funny to me.
All right. Well, you know that's okay.
I think I botched it a little bit.
I
Ms.
think
Stewart.
we're seeing, though, that minus 3 just shifts the whole function down 3 units.
Hopefully so. Right. I really messed. Yes, this 3 is my y-intercept. Of course, it's where I cross the y-axis. It's the y value when x is 0. That's supposed to be a little arrow right there. If I put in a 0 for x, or 2 times 0 is 0, minus 3 is negative 3. Again, that's my y-intercept. And of course, you probably remember the standard form of linear functions. Y equals mx plus b. Of course, m is my slope, so 2 is the slope. And b is the y-intercept. It's the value that you get when you fill in a 0 for x. I think sometimes students forget that that's really what that means.
And that puppy right there, y equals mx plus b, is called the slope-intercept
Yes,
form.
it's the slope-intercept form, and in a moment, Ms. Stewart is going to talk about another form of writing linear equations.
So, Mr. Haas, you did a lovely job with the y equals mx plus b. the
Well,
point
thanks. I
slope.
kind of botched that last line there, but
Well,
hopefully
just
you
the
get
graphing.
idea.
I
Right.
mean, everybody knew they were
Yeah,
supposed
okay.
to be parallel. I
Just have
think.
trouble drawing straight lines.
Yeah, that's fine. We're
So
going to talk about my favorite form of a line, which is the point slope form.
So what was I doing? Slope
You
intercept?
were doing slope
Slope
intercept.
That's y equals mx plus b.
Y equals mx plus
Okay,
b.
got
yeah.
it, okay.
And a lot of times students look at this and say, well, I can't memorize that. Well, if you know me, I'm not much of a memorizer. So let's just remind ourselves where this comes from, right? And it comes from stuff that we learned in middle school. Slope. Good old slope is the change of y over the change of x, right? And I think when you first learned it, slope looked like this. One of the y's minus the other y divided by one of the x's divided by the other x. Okay? Do you see a resemblance between these two things, Mr. Haas?
Yeah, sure.
Uh-huh.
Sure, I think you multiply both sides by the denominator there. Yeah.
Yes, which is legal to do. Multiply both sides of the equation by the same thing. By multiplying and dividing, those become a 1. I'm left with y2 minus y1 equals the slope, which I'll just put in the front. Holy smokes! I'm looking pretty good here. I'm just going to erase those. That's y now, and that's x. If I just bring this over here and this over here, I have this point slope form. It's just slope, rewritten. Let's see how this works. Mr. Haas, give me a slope.
3,
Excellent choice. Give me a point.
1, 2. You know what? I'm gonna be a little bit crazy. I'm gonna say negative 1, 2. It'll be a little bit trickier.
Okay. I'm loving it. So we have a line that goes through the point negative 1, 2. Okay. It has a slope of 3. I can graph this quickly, right? So up 3 over 1, up 3 over 1, or down 3 over 1. So boom. There's my line. How could I write this equation using point slope? Easy peasy. I'm just going to replace this y with this y. The slope is 3. And now I have x minus a negative 1. Well, those two negatives give me a positive. And I am done. That is a legal, kosher way to leave an equation of a line.
You can just leave it like
You
that?
can leave it like that.
That's the equation of the line?
That's the equation of a line. Everybody knows, oh, this line goes through 2, negative 1, and it has a slope of 3. It gives all the information we need.
I am going to write the equation of this line right here, passing through these 2 points, and I'm going to use my slope-intercept form of the
Excellent.
equation. Okay, so the first thing I'm going to do is find the slope. This should be pretty easy peasy. That's just change in y over change in x. So I'm subtracting my y values. 3 minus 1. Oh, can you get me up there? Am I up too high?
I'm getting you.
Okay, and my x values are negative 2 minus 2. So my slope is 2, negative 2 minus 2 over negative 4, also known as negative 1/2. So that is my slope.
Excellent.
I'll just fill that in. So I have y equals negative 1/2 x plus b. And now I have to find b, that's my y-intercept. Now I can do that just by plugging in some xy point. I can pick any xy point I like. I have 2 nice points here. Maybe I'll use this one. I like positive values, so I'll use this xy point, and I'll just plug in a 1 for y. Negative 1/2, and x is 2 plus b. So that is a negative 1. 1, you still got me here?
I still have you.
Negative 1 plus b, and so I'll add 1 to both sides. So b is equal to 2.
Oh, which we can kind of see from the little...
I think it
Graph
works.
there.
So my equation is, let me rewrite the whole thing, is, well, I'm just going to fill it in right here. I'm going to cheat. Is that all right?
Totally fine.
All right, so this is my linear equation.
Hang on. Yeah, okay, anytime.
Here's my easier way, Mr. Haas. Point slope form. Gotta love it. So, you did the work for me already with a slope, so I'm going to put the slope in here. And for this, I don't need to find the y-intercept. I just use one of the points and plug it on in. So let's use this point, the point you chose. I'm going to replace the y with the specific y from that point. And I'm going to replace this x with the specific x from that same point. And I am done. There's the equation of the line.
Huh.
That's it.
You could just leave it like that?
I can leave it like that.
That is, now, could you rearrange that somehow just to show that that is in fact equivalent to the other form of the
I
equation?
surely could. I surely could. So how should I do that? Let's distribute, and I'm going to add this 1. So I'm going to distribute that -1/2. So that's going to be +1, and I'm adding 1, and voila. Isn't that what you got? -1/2x
That's
plus 2?
exactly what I got. Brilliant, Miss Stewart.
That is so cool. Hey, could I have chosen the other point instead?
Absolutely.
All right, let's do that and see if I get the same thing. What the heck? So that y would be a 3. That x is a -2. So again, it would be x minus a -2. Could I leave it like that? Absolutely. But should I rewrite this just to convince ourselves it's the same? I'm going to add the 3, distribute the -1/2. Holy cow, they're all the same. 3 different ways to write the same line. Isn't math the coolest?
Excellent. Thanks very much, Miss Stewart.
Thank you.